Ladies and gentlemen, if you'll come in and take your seats, we'll go ahead and get this session started here in about 2 minutes. So those of you that are in the back and just outside and so forth, if you come on in and take your seats, move up as close as you wish to the front. For the members of the press that are here, we have a press package that's been prepared by the Joint Strike Fighter Office. And if you'll check with me during the intermission or the break or any time this morning, we'll be glad to provide you this Joint Strike Fighter press package, which has a lot of information in it.
Although I got to tell you, I think it's early in the morning for people that have a real interest in this. The guys happen to walk through our ears. We're going to sit down.
I don't know. I'm going to do it standing up, I think.
The next conference is in Niagara, Convention Center in Gifu, Japan. Don't miss sign up for that first. Don't miss it. Japanese pavilion.
A special thank you to our sponsors: Lockheed Martin, Boeing Defense and Space Group, McDonnell Douglas, Sikorsky Aircraft Corporation.
Good morning and welcome to our Joint Strike Fighter Day. This is going to be a very interesting day to you all. We have a great program. We have a very distinguished panel of customers, and I think you're going to find this session this morning and this afternoon extremely interesting. Our moderator today is Major General Joe Anderson, currently the Vice Commander of the Naval Air Systems Command. He's a graduate of the Naval Academy. Also has a MS degree from the University of Southern California. Went through Air Force pilot training in 1970 and the Naval Air Test Pilot School in 1976 and Naval War College in 1986. He served with VMFA 314 and VMFA 115 in the Republic of Vietnam and Thailand. He transitioned from the F-4 to the Aviate Harrier and served with VMA 231 and VMA 542. General Anderson's other assignments include test pilot at the Naval Air Test Center at Pax River. He was a commanding officer of VMA 331, the 2nd Marine Aircraft Wing, and he headed the Offensive and Air Support Branch Aviation Department, Headquarters, Marine Corps. In 1990, General Anderson became commanding officer of Marine Aircraft Group 13. He then served as military staff assistant, special assistant to the Director of Tactical Warfare Programs in the Office of the Undersecretary of Defense for Acquisition and Technology. While serving in this capacity, he was selected in December of 1993 for promotion to Brigadier General. He then became Director of Operations Division, Plans, Policy, and Operations Department, Headquarters, Marine Corps. It's with great pleasure that I introduce your moderator for this morning, Major General Joe Anderson. Joe?
Thank you, and good morning. I'd like to point out a couple things. First, to the panelists, what I have here is a machine. You can see it on my desk. It has electrodes strapped to all your seats in case any of you have any intention of saying something bad about the United States Marine Corps. The other thing I'd like to tell you all is that I've asked for bios. First of all, for truth in advertising, this is not General Mueller, that's not Admiral McGinn, and that's not General Dakin. I'm not Joe Anderson. Aside from that, you're getting exactly what we advertised. These are the actual worker bees, and I appreciate all of them coming up. And I'm going to introduce each of them and give a little bit about their background. I asked them for bios. I told them if they didn't give me a bio, I would make something up, and we have some of those people this morning. So I'm looking forward to it. On the Joint Strike Fighter program, I absolutely appreciate it. I'm a member of American Helicopter Society and a great fan of Joint Strike Fighter. In this coming together at this forum is something I want to thank Rhett Flater and thank the American Helicopter Society. It's a great place to showcase Joint Strike Fighter. The Joint Strike Fighter program is going to develop and field an affordable, highly common family of next-generation multi-role strike fighter aircraft for the U.S. Navy, the U.S. Air Force, the Marine Corps, and our allies. The UK is a collaborative partner. Norway, Denmark, and the Netherlands will soon join. Additional foreign participation is expected. The cornerstone, and I think Admiral Steidel will tell you, the cornerstone of the Joint Strike Fighter program is affordability. It's reducing development costs, production costs, and ownership costs over the entire life cycle of the weapon system. The Joint Strike Fighter, I'd like to point out, is also a model of acquisition reform, emphasizing technology maturation and concept demonstrations in early cost performance trades integral to the requirements definition process. In March, the Joint Strike Fighter program was presented one of 4 David Packard Excellence in Acquisition Awards. The Packard Award recognizes the best DoD acquisition integrated product teams from the Navy, Special Operations Command, Ballistic Missile Defense Organization, and the U.S. Air Force. And Craig, I think you and your entire program are to be commended on that particular feat. So we're delighted to have the program manager here today. We're delighted to have the requirements people and the heads of aviation of all the services, representatives of those heads. And I'd like to start out with Admiral Steidel. Admiral Steidel is the director, as all of you know, the director of the Joint Strike Fighter program since August 1995. Hear me? Okay, it's kind of on and off. Please, if you can't hear me, raise your hands, or I'll notice when your head's not off. I assume that most of you can't hear me already. I'd like to point out, before I go through the rest of Admiral Steidel is looking for dinner partners tonight. In the past, he's thrown rolls, he's spilled wine, but he's hoping to have a chance to speak to each and every one of you contractors today. So don't hesitate to grab him by the hand. Admiral Steidel graduated with merit from the U.S. Naval Academy in the August class of 1968. I myself graduated in the top 90% of that same class. Admiral Steidel has over 3,600 hours in over 50 aircraft, including the F-18, the A-6, the F-4, the A-3, the H-2, and the Sea Harrier. He's an attack pilot who flew night missions from carriers over North Vietnam. He has commanded the Navy's A-3 program. He has commanded the F-18 program, Naval Aviation's largest production research and development program, as well as the largest foreign military sales program. He was presented the Navy's Outstanding Program Manager Award by the Secretary of Defense while serving as the F-8 and A-18 Program Manager. The Joint Strike Fighter, under his tutelage and under his leadership, was awarded the Packard Excellence in Acquisition Award by Secretary of Defense this year. And please join me in welcoming our Program Manager for Joint Strike Fighter, Admiral Craig Steidel.
Thank you, Joe. Appreciate it. Thanks for the dinner invite. You hear me back there? Okay, and you know, one? All right. True story. I gave a speech one time at a suppliers conference in St. Louis. The fellow waving in the back, some of you have heard me say this before, said, "I can't hear you." And the program manager up here in the front was Larry Lemke at that time. He says, "I've heard him before. Let's swap places." So I asked Joe before we started here if he heard my last brief. He says, "I certainly hope so." But unfortunately, you got one more, Joe. I'm going to talk just very briefly. I'm going to go through just a quick synopsis of how we got to where we are today, 40 years worth in 3 slides. And then I'm going to turn it over to the people we should really listen to, the warfighters, the czars from each one of their services that determine the requirements and where we're headed in the future. So I'll go quickly through this. Next, please, Jay. Certainly, we're here discussing Joint Strike Fighter Program. It's definitely a joint program, and as Joe described when we started, we're here for a joint service team creating the building blocks for an affordable, successful development of the next generation strike weapon system. That means we're going to produce a supersonic Stovall strike fighter in the very near future. We, as you can see, there's 4 up here right now. The UK is a full collaborative partner, fully integrated in the office and in the IPTs. Secretary Dr. Kaminsky signed an MOA with the Netherlands and Norway about 2 weeks ago. They are on board. We expect Denmark to join the program sometime in the very near future. I have a team in Canada right now discussing the last parts of the MOU with them. They will be joining the program. I expect that signing probably in June timeframe. And we've got a lot of interest internationally on the program. But let me quickly just take a step back and show you how we got to where we are today. Next, Jay. First, I'm going to show you this picture. Some of you have seen this. Some of you may have been associated with this program. Probably not too many as I look out here. We built 2 of these airplanes, XV-3 tilt rotor. It first flew in the 1950s. We lost both of the airplanes. We lost one in flight. We lost the other one in the wind tunnel. We had a wing blade interaction problem, but it proved the tilt rotoring concept. Next, please. XV-15 tilt rotor. One of them still flying. Built 2 airplanes, first flown in 1978. It was successful out to 300 knots and was successful, went aboard an LHA. It demonstrated the concept and then proved the technology. Next, please. Of course, the V-22, you can see some out here in the spaces. First selected for full-scale engineering development in 1986. It was canceled by OSD for affordability. You'll see that theme throughout my presentation, and certainly any of you associated with the Joint Strike Fighter program know that that's one of our primary pillars. It was restarted in 1990 by Congress and is an EMD and is doing extremely well. That was the start. Let's just refresh that. What have we learned from these? Well, we learned, first of all, technology is extremely complex. We know that. We know that that has been overriding a limitation on why we can proceed faster and into some of the new generation systems that I'll be describing later on. But the XV-3 proved the concept. We learned that cost and performance trades are necessary early in the design. That was reflected in some of the design work done early in the XV-15 program. You need to make those designs early before you start an EMD program. And we learned from the start of the V-22 program, the cost of ownership and affordability is extremely important as you go down the pike of a program. Next, please, Jay. Back to history. This is the Kestrel, first flight in October 1960. P-1127, and that was a supersonic airplane. If you pointed the nose straight down at the ground, it did achieve supersonic flight. However, its capabilities were limited at 1,000 pounds. It can hover for 2 minutes. We built 9 airplanes between 1964 and 1965 and commenced operations in April of 65 with a group sort of like an ACTD program today, the US, UK, and Germans. But it did demonstrate that this concept was indeed valid. Stay on that chart for a second there, Jay. I want to take a departure. In the summer of 1961, a requirement went out for a supersonic Stovall strike fighter. It was a specification that went out. The weapon system had to go 250 nautical miles. It had to fly on the deck, 0.9, carrying a 2,000-pound payload. airplanes were going to be needed 5 years down the road. In 1966, there was going to be 12 aircraft squadrons. The Royal Air Force and the Royal Navy wanted that particular aircraft. They could not come to an agreement on a specific operational requirement. They went in two different directions. They did not compromise. There was not a warfighter technologist pulling these pieces together. And as a result, the Royal Navy went with the Phantom, and the Royal Air Force went with the Harrier. We've never done that before, have we? So I'll show you how we get around that and how we're handling that now. Next, please. Eventually, we did get to the Harrier, AV-8. It was the first operational use of this particular concept. It did have limited range and payload. You started out in the AV-8A. Fantastic. It did not address, however, cost of ownership. Moved on, next, to an upgraded version. My special assistant is a Harrier test pilot as well, flying the A's and the B's. New wing put on the airplane. The Royal Navy went with an upgraded radar system. A tremendous performing airplane. Still, cost of ownership has not been addressed in some of the other aspects that we will be addressing in the Joint Strike Fighter program. What did we learn from that particular tree? First of all, let's just refresh that. We had the first Harrier. It proved the concept and the technology. Went on to the Generation 1 Harrier. It developed that particular concept. It was combat proven. Went on to the Harrier 2, and that was increased performance, and we kept on making moves in the right direction. Then there was the ultimate Harrier. That was the P-157, and that was going to be a fan stream burning airplane. That's plenum burning, where out of the front nozzles you actually burn some of the fuel, and you'll have a 12-foot plenum or 12-foot plume down the side of the airplanes. It was demonstrated on the ground. It was going to be catapult launched, supersonic, vertical recovery capabilities, and it was linked to the Royal Navy's CVA-01 program, which was ultimately canceled. So that was the stop of the growth of the Harrier program at that particular time. That brings us to where we are today. Next, please. Sam Wilson put this together for me. I'm sorry you can't see this, but this is the wheel of misfortune. There's 45 different programs on here that tried to accomplish and tried to develop in some way a supersonic STOVL strike fighter. There's a couple of them that made it. On the about the 4 o'clock, there's a V-22. The Harrier's up there about the 5 o'clock. Boeing's X-32 is on there around the 6 o'clock. Lockheed Martin's X-35 is up there around 10 o'clock, and the Yak-38's there about 9 o'clock. It's worth looking at some of these programs and the attempts to do what we're going to achieve here shortly in a little less than 3 years. Next, please. So what do we need to do? First of all, big terms, we need to balance, as you can see, the requirements and capabilities against the technologies that are available today, and do that affordably, or else we're not going to have a successful program. Next, Jay. We need to make this affordable. You've seen, those of you that have heard me have seen me use this chart. This is Mr. Augustine's chart. Up the side, he's got unit recurring cost, the cost of one weapon system, one airplane, with actual data points on here. Here he has the defense budget, where the entire defense budget can afford one airplane. An opportunity, my deputy, General Kenny, and I met with Mr. Augustine yesterday, and his comment was, I think we're going to make it. We're going to make it with the Joint Strike Fighter program, and by that I mean we are going to get off his chart and get down in this area right in here and do things differently. Next, Jay. So why now? Why can we do this now? Well, technology has moved progressively and very, very rapidly in the right direction to allow us to achieve this. From the engine technologies, we've now got the thrust and weight, we've got the temperature, the materials, and the cooling. There's some very, very significant things that are going on. In fact, I think there'll be an article on some of the things we've achieved very recently in either the next or the one after that, Aviation Week. Please look at that. We've made some tremendous inroads in that particular area. Integrated flight propulsion controls, digital systems, and FADEX, and the combinations of those digital systems with digital flight control systems. Very important to achieving what we want to achieve. There's structures and materials, unitized composites, innovative concepts, and you see some of them out here today as I quickly walk through. I'm going to spend more time today. Integrated subsystems, diagnostics. We've got a diagnostics display out there I hope you'll look at. Multifunction arrays, paintless airplanes that are flying right now, smart maintainers, and commercial off-the-shelf. All this pulled together is going to allow us to take that next step beyond that wheel of misfortune. Next, please. So what we're going to do is, as reflected here, we're going to balance the life cycle cost, the cost of ownership of this particular weapon system against lethality, supportability, survivability, and we're going to do it from an affordable standpoint. Next, please. Well, where do we get to? Well, let's take a quick look at a couple, and I'm not going to go into these in details because there's some tremendous presentations outside there from Boeing and Lockheed Martin. Let me just quickly refresh them. Next, please. Boeing is out here, out towards the front. I just looked at that. The Secretary of Defense on the 16th of November announced our selection of Boeing and Lockheed Martin to enter into the next phase of the program, where we're actually going to demonstrate commonality, modularity, hover and transition, up and away flying qualities, and flying qualities behind the boat from a carrier suit version. And that's what they're going to be building. We're actually building airplanes today. We're milling pieces. Parts are coming together. Build-to packages are on the way. And between 2.5 to 3 years from now, we'll have these airplanes in the air flying and testing. Boeing's model here, that's good, Jay. Boeing's model is a thermoplastic inducted welded wing. It carries, for the Stovall version, 2 1,000-pound bombs and 2 AMRAAMs internally, 4 wing stations. It's got a 2D vectoring nozzle on the back end that closes. A Harrier-type concept. You'll get more description on that in this afternoon. I believe Dennis Mollenberg is going to give you a brief. 2 nozzles in the back and a nozzle up forward. 4 wing stations, as I said, and we'll be flying that in a couple of years from now. Go to the next one where I talk about each one of these concept demonstration vehicles will be flight tested at Edwards and at Pax River. They'll be showing airworthiness, aerial refueling, flying qualities, standpoint, hover and transition, flying qualities, as I mentioned. Lockheed Martin is right outside the door here. You can see their vehicle. Next, please. It's got a bomb bay with 2 2,000-pound bombs, 2 AMRAAMs, 4 stations. It's got a 3-bearing nozzle in the back end for the Stovall version, a shaft going forward to an Allison Rolls-Royce GE fan up in the front. They've got a very good model of it outside that you can look at and discuss that later on. Dave Wheaton is discussing that this afternoon, I believe. I'm very excited. We had 3. The last time I had the opportunity to discuss a group like this, it was before we made our down select, but we had 3 outstanding proposals. It was very, very difficult as we went forward. This tremendous industry has done a tremendous job pulling this together, and we're very proud of where we're at and where we're going. Acquisition reform. Dr. Comiskey briefed you all yesterday, and we would not have this program if Dr. Comiskey was not there. He allowed us to operate in a new area, acquisition reform. He allowed us to open up our process, our initial requirements document, and these individuals up here have allowed me to work within a space of making cost and operational performance trades that have allowed us to keep the costs down. We're open with industry. We share our RFP with industry. We're doing business differently. Common cost model that we've shared with industry, open architecture, open system architecture in the avionics world, a virtual strike warfare environment where we can actually play the systems before we put them in the air. That's different. That helps us bring the cost down, demonstrate those capabilities first, reduce the cost of development and training as we follow on. We're on the World Wide Web. We do everything digitally, and it's a new way of doing business that Dr. Comiskey has allowed us to operate. That's going to help us achieve what we're trying to do. Next, please. I've also noticed a significant cultural change in business, in industry as I've gone by. On the left side is a traditional way of an airframe prime dictating the requirements, passing them down to the avionics suppliers, and the avionics suppliers taking those boxes and trying to fit them into that particular weapon system, the full integration still being done and dictated by the primes. I see now weapon systems requirements being established by the primes, and the capabilities of the avionics houses coming together and defining in a trade space what's going on in that weapon system. It's working very, very well. Next, please. Additionally, industry came back with this. This is a representation, and this is significant for our program. This is a representation that shows that with technology today, we are capable of developing a single production line where along that production line we can have a high level of airframe commonality, 60 to 65%, supplemented by commonality of displays and seats and software and test equipment and support equipment, bringing commonality up above 85%. And down that production line you can build one strike fighter and then branch off into variants of that. Either put a lifting fan system into it or a lifting system of some type with the nozzles and the blockers, or the Navy characteristics that are required for a carrier-suitable version of the airplane. And out comes 3 versions of that weapon system. Industry brought that to us and proposed that, and a significant enhancement. That's going to allow us to do that. What it also allows, in order to make this program viable, is what you see in the lower box here. These are traditional programs for a STOVL airplane, a conventional takeoff, or a carrier airplane. The typical costs are between $10 and $11 billion to do an engineering, manufacturing, development program, for a total of $33 billion or so. We're doing the program for, as you can see right here, about $16 billion. That gives viability to the program and allows us the opportunity to make those demonstrations come to fruition. Quickly, this is where we are. I went through this piece right here. There are 45 programs trying to achieve what we're going to ultimately get here. The Harrier has done it. The tilt rotor has done some of those demonstrations and proved those particular concepts. But today, through the use of increased propulsion capabilities, integrated flight propulsion systems with the control systems, the materials, bringing down cost in order to keep this program alive and keep it tracking and bring the cost of ownership the fleet has to provide for these weapon systems in the out years. We're going to be able to do this. We're going to successfully, in 2.5 years from now, have a supersonic STOVL jet fighter flying for all 3 of the services. Next, Jay. I think you'll see this. This will be reflected. This is where the Department of Defense is going. F-18EF is coming out. F-22 following that. Joint Strike Fighter in the out years for all, right now, 4 services. We've had a lot of help from Dr. Comiskey on up and from Dr. Comiskey on down. A lot of support for the program. We're doing very well in Congress this year. We're speaking from a forum of affordability, doing things differently. People are giving us the opportunity to demonstrate some of those acquisition reforms and new ways of doing business. We've got a lot of, I've asked a lot of my IPT leads to present some of the tech maturation programs out there. They're there. I recommend that you go and look at them. We've got some demonstrations flying, as I told you, paintless airplanes, some integrated subsystems are underway. This is the way we bring the program cost down. Let me show you what all that help brings. This is a program director in Washington. This is my supporting cast all over the world and across the river. Next, please. We're on the World Wide Web. Please use us. We have an average of 700 inquiries a day. We've gotten up to a high of 1,100 inquiries a day. Most of our briefings are on there, our RFP and everything else we do, where we're going, what's happening, congressional updates that we have are on that World Wide Web. Please use it, and also you can send in questions and we'll respond to them accordingly. I'll be available for questions later on and throughout the day, but thank you very much for inviting me back here for this symposium.
Thank you, Craig. What I'd like to point out here is our format for this morning. We have all the requirements, people. We look forward to your questions. We have time set aside for your questions. I'll ask 3 speakers to speak here. We'll take a short 10-minute break, come back for the last 2 speakers, and then open this up for questions and answers. So that's the current plan. Next, I'd like to introduce Brigadier General Bob Magnus. He currently serves as the Assistant Deputy Chief of Staff for Aviation at Headquarters Marine Corps, Washington, D.C. General Magnus was born in Brooklyn, New York, and is a graduate of the University of Virginia. He is, after completion of flight training, he was converted to the CH-46 for training and deployed with the Landing Force 6th Fleet crews aboard the USS Incheon. He then went to Headquarters and Maintenance Squadron 15 as a Search and Rescue Detachment, Task Force Delta in the Royal Thai Air Force Base, Namphong, Thailand, also known as the Rose Garden. Truly a wonder spot. He deployed with the 6th Fleet with a cruise aboard the USS Iwo Jima, then was a weapons and tactics instructor in Marine Air Group 26. He served as the Aviation Weapons Systems Requirement Branch in the Weapons Systems Requirement Branch in the Aviation Department, He then became Executive Officer of Medium Helicopter Squadron 365 and assumed command for his 4th 6th Fleet deployment aboard USS Iwo Jima. In 1989, General Magnus reported to the Joint Staff, where he served as Chief J4 Logistics Readiness Center and as Executive Assistant to the Director of the Joint Staff. In 1993, General Magnus reported to Headquarters U.S. Marine Corps as the Head Aviation Plans, Programs, Doctrine, Joint Matters, and Budget Branch. And representing the Marine Corps, we have General Magnus. We appreciate him being here. Prior to his participation in the Quadrennial Defense Review, General Magnus was 6 feet 4 inches.
Thank you, and good morning. I'm not so sure that the footage I lost there was from the top or from the bottom. I'll assume it was from the bottom. But Marine Commandant General Chuck Krulak likes to say that short is in, so I'll feel privileged to be able to represent General Krulak and the 174,000 active Marines that are out there today. As you can see, I'm obviously not Lieutenant General Terry Dake. The reason why General Dake is not here is basically the reason why some of your other featured speakers were not here. We're in the end game of the Quadrennial Defense Review. We've been doing a great job from an operator and requirements point of view of defending the urgent need, both from an operational perspective as well as from a fiscal perspective for the Joint Strike Fighter. As you can see, I'm going to start out telling you why the Marine Corps needs the Joint Strike Fighter, but I want to tell you that the nation needs the Joint Strike Fighter. The Joint Strike Fighter, actually its predecessor, the JAST program, basically came out of the bottom-up review where it was very clear that Augustine's curve was going to break the back of the Department of Defense. We were not going to be able to have the nation's tactical air forces recapitalized based along that trend line. So not only does the Marine Corps have a unique requirement, as do the other customers for this aircraft, but the nation has got an urgent requirement for tactical air and an affordable tactical air. The Marine Corps, chartered in law, is to be the service that is ready when the nation is least ready. Clearly, we in the Navy are naval in character, forward and from the sea. Marine Corps also uniquely chartered after the Korean War when it was recognized that the nation needed to have a combined arms team in a single service. So where you've got ground combat, aviation combat, as well as service support, able to go to war as a team from the get-go. We are also expeditionary, soldiers from the sea. Our capability is to transition from the sea to the shore, and as you've seen in Somalia and other places, to roll it back from the shore to the sea so that we have the most flexibility for the nation in international airspace and sea space, and the most flexibility for the SINC in our ability to get into and get out of the theater without the kind of footprint, airports and seaports that may not be available in many future crises. Marine Corps Aviation is a critical member of that team which evolved in the earlier part of this century, was proven in fire in World War II, Korea, and Vietnam. And what you basically see here is that our aviation is tailored to the needs of the situation, whether it be a crisis like Liberia or a non-combatant evacuation in Zaire, denied flight operations that are in the southern region of Europe or in the Southwest Asia. But basically, we provide the Marine Air Ground Task Force with its mobility, with its firepower, with its integrated capabilities to surveil the battlefield and support the infantrymen on the ground. The key to the Marine Corps is our ability to focus on the needs of that Marine rifleman on the ground. Like I said before, we're expeditionary in nature. One thing that's happened with the enormous growth in the capability of TAC Air since its early inception in World War I and Marines developing things like close air support, fighting the Sandinistas in the 1920s in Nicaragua, was that as our aircraft got more capable and went from single to multi-engine recips and then to jet-powered aircraft, the need for support facilities grew almost exponentially. Whereas in the 19 teens and 20s and 30s, aircraft typically operated off of grass strips and as was dramatically proven in the numerous bases that dotted this country and the UK during World War II. As the aircraft got heavier, as the engines got longer performance, the demand for 8 to 10,000 foot runways increased, and so our footprint in the theater became more and more difficult to sustain. The picture you see here is the original Joint Air Force, the Cactus Air Force that was during the invasion of Guadalcanal in 1942. At Henderson Field, you had VF-5, a Navy squadron, you had Army Air Corps Airacobras, and you had the Marines that came ashore to support the 1st Marine Division. They were obviously operating in an expeditionary environment, literally in an airfield that the Japanese had hacked out of the jungle. We could not do that as we introduced tactical jet aircraft. The purpose of the STOVL part of the Joint Strike Fighter program is to bring back the mobility, the flexibility, and responsiveness that Marines enjoyed in World War II and Korea with the capabilities of modern jet aircraft. And one other thing I will point out about that is people talk about how difficult it is to be joint. I don't think we even really understood the term back in the 1940s as it is used or misused today, but I can tell you that the soldiers, the sailors, and the Marines that were basically supporting the division on the ground in Guadalcanal had no problem at the operational level defeating the Japanese Army and the Japanese Navy as they moved up the Solomons. And in fact, the basic flexibility that you see in that one slide was that the Marines carved out an aircraft carrier to be able to support the fleet as it moved up the Solomons. It's the mobility of STOVL that brings us back to the capability we enjoyed at World War II. So I guess I'm going to bring you back to why STOVL. I gave you a piece of that already, but it's literally, currently we are forwardly based, both the Navy and the Marine Corps, as well as our sister services. We learned the lesson in the island hopping campaigns in the Pacific, and it's not that we learned something and we can't forget past lessons, but they have enormous application in the future when you may have, whether they're friendly nations or unfriendly nations, that may either give you limited or no basing access, or when you're forced to come from the sea. It also gives you the capability with STOVL to do basing dispersal, with the ability to not only use relatively short runways, which is certainly the case with aircraft like the F-18 and the F-16, but where in fact those runways are interdicted under rocket or missile attack, you have the capability to disperse from main operating bases. You have the capability to use twice the large decks, not only the carriers, but the large deck amphibs, and 5 times the number of airfields are available in the theater. And along with that, the Joint Strike Fighter will bring us the essential component of that is not only not the runway, but not the enormous logistics footprint that goes along with supporting tactical jet aviation. Just a little anecdote here. I was talking just a few weeks ago with the Israeli air attaché. Some people have different reasons why they would want to have STOVL capabilities. Imagine yourself 10 or 20 years in the future with a fixed air base where the enemy knows exactly where you are in peacetime, and yet dispersing to hide sites under threat of an enemy rocket or missile attack. Something we thought about when we were looking at the Fulda Gap. There are other nations that have similar concerns, and so therefore STOVL capabilities in TAC Air are going to be increasingly important as the threat proliferates rocket and missile capability. JC? As you can see, the Marine Corps is obviously not a shrinking violet. I'm proud to be first among the operators here because the Marine Corps brought us close air support. The Marine Corps brought us the integrated combined arms team. The Marine Corps pioneered in the United States the technology brought to us by the British and the Harrier. You can see that we introduced the Harrier, upgrading it in the top center there to the AV-8B from the AV-8A. We brought the B online in 1984. We'll bring the Joint Strike Fighter online with production aircraft in the year 2008. We see the Joint Strike Fighter as the maturation of TAC Air STOVL technology. At the same time, the Marine Corps was moving forward, as you can see, to fulfill Commandant General McPate's dictate in 1957 to get to an all-STOVL aviation force. We started out in the 1940s, 1948 there. You see our flying banana. Moving forward into the 1960s, adopting essentially civilian helicopter technology with the Boeing VTOL 107, that's the CH-46 in the center. We took that into Vietnam in 1962 and beyond, and we're flight testing the MV-22 Osprey today, and it'll have its initial operational capability in the year 2001. So well before we get to Joint Vision 2010, the Marine Corps will have begun to fulfill Commandant McPate's vision. Next slide, please. On the TAC Air side of the house, you'll see what Joint Strike Fighter is doing, not only to lessen that logistic footprint, but also to lower the cost of the procurement and the sustainment of our aircraft, is we've done a very dramatic neck down of our different type model series aircraft that we've possessed since the 1980s. You can see the chart where we took our tactical aircraft that were developed in the 1950s, 1960s, and 1970s, from your F-4s through your F-18s and the A-4s. We currently have necked them down to the three type model series you see there, the F-18Cs and Ds, and the AV-8Bs, which will serve us very well while we take the strategic pause afforded to us by the collapse of the former Soviet Union and take the technology leap into a single type model series aircraft with those STOVL capabilities, the Joint Strike Fighter. As you can see, our Joint Strike Fighter is required to fulfill many missions in one type model series for the United States Marine Corps. It's going to be our offensive air platform. It's going to also be our anti-air warfare platform to the extent that it needs to self-protect or protect our own bases. It's going to provide us the aerial reconnaissance capability, which we are just now recovering with the Advanced Tactical Airborne Reconnaissance System, which will go into the F-18Ds because it will replace the F-18Ds. And of course, as the F-18Ds are demonstrating that capability now from Aviano and from Iwakuni, it's going to perform the tactical air control, airborne, and the forward air control mission, the TACAFACA mission, as well as the reconnaissance mission, so we can be able to provide close air support, direction of assault aircraft, strike aircraft to the infantrymen back on the ground. Again, the emphasis is on air to ground, clearly. Our mission in life is to support the riflemen. Commandants of the Marine Corps would not support the substantial cost of marine aviation if marine aviation was an integral part of that combined arms team I talked about earlier. And as you can see, in an affordable aircraft, we're going to combine the best capabilities of our two premier aircraft today, our Harriers and our Hornets. You've all already heard Admiral Steidel give you a capsule of what Joint Strike Fighter is bringing you. I'll let you be able to take a look at that. Essentially, what we're looking for is superior air-to-ground capability, not only with its inherent very low signature capabilities and onboard countermeasures, but the air-to-air and digital weapons that are going to be essential to be able to fight, survive, and accurately strike targets in support of that rifleman in the future. We're going to have supporting subsystems such as the ESA radar, integrated avionics capability, and an all-weather precision strike capability with those digital weapons that I mentioned. It's basically going to give us the capabilities that you see in the lower left-hand box, and we compare those to the F-18 Charlies, which are going to be our premier strike fighter well on out into the 20-teens when we replace the last of the F-18Cs in the Navy and the Marine Corps with Joint Strike Fighters. Next slide, please. So the Marine Corps' STOVL Strike Fighter is going to give us that expeditionary tactical aircraft that we could not get with the jets that were developed in the 50s and 60s and 70s without bringing an extraordinary large and vulnerable footprint into the theater. It's going to give us an affordable capability for the nation's 911 force. And as you saw when Mr. Flater introduced that video for the AHS forum here, that hummingbird, which is the symbol of the AHS, is really memorialized in that statement from Thomas Edison. Until you had a STOVL capability in tactical air, you did not get the true flexibility that Marines not only seek, but absolutely need in order to be able to do our expeditionary mission. Thank you very much, and I look forward to your questions later on this morning.
Thank you, Bob. Our next speaker is Rear Admiral Carlos Johnson. I was about to tell you that this is the Navy's only published poet and accomplished cellist, but then he gave me his bio. Carlos has in excess of 4,500 hours in light attack, 1,300 plus carrier landings, has flown the A-7, F-18, A-6, and F-14. He also has over 100 hours attempting to keep helicopters in the landing zone. He's flown Hueys, H-3s, H-60s, and H-53s. Carlos has commanded Fighter Attack Squadron 86. He was Deputy Commander of Carrier Air Group 3. He commanded Carrier Air Group 8 on board the Theodore Roosevelt. He's made 11 deployments from Vietnam, 130 missions there, to the Mediterranean, to the Persian Gulf. Shore base, he's been General Sheehan's executive assistant in ACOM, and he was the Deputy Chief of Staff for Air, Land for Readiness and Operations. He was the Director of Special Operations and Intelligence for SPEAR, and now he is the Head of Aviation Plans and Requirements, N880. Please join me in welcoming Carlos. We appreciate you being here and giving us the Navy view.
I guess the Navy must be doing very well in the QDR. I was 6'4" when I went to the job. I'm 6'6" now. So I think Admiral McGinn is up there fighting a good battle, and the story I'm about to tell you is part of that. The JSF is an integral part in trying to gain clarity in today's crystal ball to look out into the mid-2010, 2015 area. And that is part of the story that naval aviation had to re-wicker, and much of the leadership I see in this audience participated in that when the wall crashed in '89 and the A-12 crashed in '91. So we had to come back and we had to look at naval aviation across the board to make it, as Admiral Stadel said, very affordable for our nation's needs in the future. This is a large part of that story. Next, please. We look at the U.S. Navy needs as meeting our nation's requirements for those forward deployed aircraft carriers that we send around the world to be the 911 force of America. That force acts in concert with a lot of things, not just the aircraft that operate off the aircraft carriers, but the cruisers that take the land attack cruise missiles with them and their air defense assets with them. And of course, the biggest part of filling an immediate need was the F-18 E&F program, which is well on track, very affordable. Part of what Admiral Stadel said, though, is very true. Much of the JSF program that exists today is immediately transferring some of the technological gains from the JSF program into our F-18 E&F program, and that is allowing us to realize some affordability issues that we had not seen in the past. But the threat-based requirement is still very cloudy out in the 2010 to 2015 region, and we feel the JSF will fill that need as we get more clarity on what these smaller third world country threats and potential resurrection of larger near-peer states might be. Next, please. This is how we look at the Naval Aviation Fixed Wing Plan. The helicopter master plan is very similar. We're necking down type and model series for obvious reasons. We will be flying F-18 Charlie Deltas no matter which plan we go with out to about 2020 as long as we maintain the 12 aircraft carriers we have today. Where it becomes very shaded and gray up there is JSF. JSF may move to the left if we realize the technologies earlier. It may move in greater quantities. It may reduce the need for 1,000 F-18 E&Fs by increasing the buy of JSF if it realizes its affordability and its capabilities that currently we envision it to fill. So the real requirement for F-18 E&Fs and the real requirement for JSF in that future time period is a planning factor. Right now the Navy is planning on around 250 JSFs to fill its needs, but that figure can go larger or it could go potentially smaller if in fact we don't realize some of those things. The same is true with the F-18 E&F. Its buy could go much smaller if we end up buying more JSFs as with an increased capability. Those planning figures are not historically inaccurate. That's the way we have done business forever. So our story in the QDR is that this is not a spike in naval aviation, and in fact, the buying curve for naval aviation is relatively flat. The increased costs of some of these individual platforms is being adjusted to by the fact we've gone from 60 strike fighters down to 50 strike fighters on board our carriers because of the multi-mission capabilities each of these platforms gives us. The next slide will talk about that transition. We are doing time-phased integration of these. We are taking out the older, higher cost, higher support cost aircraft at an earlier rate than anticipated in our past because of the strategic pause that we are currently in today. We were able to retire the A6 at a much faster rate we are looking at what we can do to neck down those higher cost type and model series and replace them with a lower cost aircraft as early as we possibly can across all the cycles of naval aviation. We have reached the growth capacity for the F-18C. That is the bottom line of it. It is today filled up at 98% of its avionics capacity. We cannot increase its capability as some would wish away our ability to do by putting some advanced defensive systems on it that require increased cooling, increased capacity internal to the airplane. We cannot put advanced radars on it that are coming to the MERS program, the F-22 program, and others such as AESA because of lack of cooling and weight growth space in the F-18C. It has filled out that capability, and without major increases in structure and changes, which equals the F-18EF program, we can't do a lot to improve its capabilities. So we have to get to those increased capabilities by doing multi-function platforms such as the EF and the JSF. Next slide, please. The performance drivers are much as Admiral Stidle said. Affordability is the baseline for everything that we have to do. We have to look at the life cycle costs across all of our platforms, whether it's the weapon that goes on the aircraft or the weapon system that delivers the weapon. The commonality that we can achieve through many of the joint programs that are ongoing today is very, very important to all of these programs. As I said, some of the multi-source integration things that have come from the MERS program and JSF are immediately realizing benefits in the Oscar program for the AV-8B and the multi-mission computer capabilities of both the F-18C and the F-18E and F. So all of these things are lending us to a reduced life cycle costs. At the same time, we are making dramatic increases in the ability of the lethality of these aircraft. We are truly moving from the world of sorties per kill to kills per sortie because of things such as JSAL, standoff land attack cruise missile, that we're developing, because of JDAM, because of all of the GPS-type weaponry that we're doing. But that multi-source integration and this situational awareness that's brought about over the last few years is dramatically increasing the pilot's awareness and his ability to utilize all of this. Next slide, please. Survivability is a key part of this. We think that the aircraft that we have currently today, combined with the concept of operations that our naval battle forces take to sea with them, gives us the survivability we need as far as that crystal ball allows us to see. What we don't know is what are the changes that are going to occur in the mobility of some of the lethal systems that are out there. And those drivers are changing today. Before, where we lost battles by having large groups defeated at sea or on land, today we lose battles by losing one soldier, one airman, having one aircraft shot down. So those drivers in survivability are changing, and so we have to look across the aircraft programs and what we put into them to give us increased survivability. And again, we've talked about supportability. The nice part about the JSF program is it is evolutionary as well as revolutionary. The ability to write its Joint Operational Requirements document for the next 3 years allows us to make some considerable trades as that crystal ball becomes more clear. Next slide. Why JSF? All of the things that I talked about before, all of the things that Admiral Stidle and General Magnus talked about and that you will hear from the Air Force. We have a series of things that need to be met in the 2015 timeframe, 2010 timeframe. Those things will be allowing us to take advantage of open architecture, the commonality, and the technology leaps that are going to occur and that have occurred. In the past, the military R&D structure drove much of that technology change. What we are seeing today is a transfer of that to where your technology out in the commercial worlds are allowing us applications never before dreamed of in our own processes. So now we have to adjust the military processes, the acquisition processes we have to take advantage of those leaps in technologies and make them more affordable in our aircraft as well as in our weapons. Next, please. This is an example of those commonalities. The gray areas that you see in the middle are all those direct transferable things that come from both of the programs in the F-18E and F as well as in the JSF. Those things that you see in the light green area demonstrate those things that are unique to those individual platforms, and then the blue areas are the growth areas for both of these. We think we're going to realize the growth areas and maintain the cost of both of these programs so that they're affordable for your nation's at-sea forces. This is what the air wing growth pattern is going to look like. To interpret that for you, gradually the first aircraft that are going to be replaced by the EF will be the F-14s. The very first squadron will be an F-14 squadron we have in excess on our carrier decks today, replaced by an E, but eventually all F-14s will be replaced in kind with the F model of the F-18. Then the EC will be with us, as you can see, considerably through the 2005 timeframe. The 2010 timeframe on the carrier decks, you will have 2 squadrons of E's, 1 squadrons of F, but we will still have a squadron of C's. Those C squadrons are those squadrons that are to be replaced by the JSF, so that by 2015 we will have a mixture of C's and JSFs on board our carrier decks, and by 2020 we will be a single F, 2E, and JSF squadron to maintain that 50 strike fighter. That doesn't mean that we'll only have 50 strike fighters on our aircraft carrier decks. The flexibility of the deck is tailorable to the missions that we go to, and certainly one of the promising technologies in the STOVL is that we can get a smaller footprint and maybe pack more airplanes onto the carrier decks than we were able to do in the past. Next, please. JSF is a catalyst that's going to provide us the ability to meet that potentially moving threat in the future. We do not right now envision that it's a near-peer threat, but it can potentially be that. You look at China today. China doesn't have an overwhelming capability other than its ability to foster a lot of people on a battlefront, but mass has some military merit. But they are like the Japan of the 1950s. The product that you get from them today that says made in China was like the product you got in the 1950s that said made in Japan. You kind of played with it with a day, it broke, you threw it away, and it only cost 50 cents, so you didn't worry about it. Well, put them ahead 20 more years. Where are they going to be 20 years from now with the advent of their opening up their markets with Hong Kong and some of the others? So they have the potential to be that near peer of the future, and Russia also has that potential to realign itself, get its act together, and who knows what it's going to be. But then there are a lot of other small peripheral nations that will have military capabilities brought about by these technological edges, but in smaller manners. So JSF is our hedge against that future threat capability, and we think that we need to maintain those technological leaps that are coming from this program. But at the same time, we want to continue to increase those capabilities that are brought about by the EF's increased size and its growth capacity, and taking these JSF technologies, upgrading the EF in a standardized manner with the commonality of the programs that come from both. Next, please. The threat will diminish over time, but we do not know clearly, again, where it's going to go. And I've talked about all of the things that each one of this thing gives you, but one of the things that JSF gives you is reconfigurability. If you need stealth in the opening battles of a 2010-2015 war, where you have to send it to where some mobile systems could impact it that you couldn't hit with your standoff weapons capability, then JSF is that airplane for the Navy. But once that increased lethality is reduced, as we have shown that we are capable of doing in the past, we can reconfigure that airplane to support the grunt on the battle lines, or a bigger impact as far as external weapons carriage throughout the envelope of all the missions that we have to do from the sea. The sortie rates and the kill ratios for this aircraft should go up considerably from the fact that if you can only carry 2 bombs and 1 set of air-to-air missiles in its stealth characteristics, if you can then reconfigure it to carry the external weapons carriage. We have proven time and again that the more weapons that you can carry, the less you have to worry about the survivability features, because you get the job done faster. That is all based upon what threats you have to face, and that is JSF's hedge. Next slide, please. This kind of gives you an idea of the battle space dominance picture of the way the Navy operates. As I said, we operate as a battle group. That includes uninhabited vehicles, such as cruise missiles that go out there and attack targets autonomously. It includes standoff weaponry, such as the SLAM ER Plus or the JASM of the future. It includes such things as JSAL, where you don't have to go into the heart of the enemy's envelopes, and JDAM, where you do. go into the enemy's envelope, but with much more precision, much more ability to kill the target, but it still also gives you the flexibility to go to the level of effort capability by being the truck to haul the extra bombs that we know from our past experiences will be required to put the finishing touches on any war. Next slide, please. So to walk through how you would use JSF in the 2020, you use it to go against those very high threat areas. You use it to supplement your SEAD capabilities, and you use it to attack those targets which you're unsure of what the threat or that the threat has been increased to such a high level around it. You complement that again with the F-18EF from the carrier decks in both the air-to-air roles as well as in the air-to-ground roles. In phase 2, next, you're going to leverage the force, you're going to decrease the amount that you have to put against a specific threat, and you're going to increase the capabilities of all those airplanes by that multi-mission functionality that you bring. Next. And in phase 3, during the assault, you put the full weight of what those aircraft can be reconfigured to be the trucks for the battlefield to meet all those missions with the maximum number of lethal weapons we can put on each of those aircraft. Now, I guess one of the other questions that's been asked of me is what is the Navy's plan with regard to the carrier mix as versus the Stovall mix? We are a wait-and-see mode right now. That's like the JORD being written over the last 2 years and what it's going to mean over the next 3 years till we fly airplanes. If the Stovall technology proves itself to allow us to do supersonic great range increases in range capabilities, then there is a great potential that the Navy's product would be only a Stovall aircraft, vice having to put the extra money into the keels and the catapult and arresting gear requirements that go against our carrier-based airplanes and increase the cost to us. So that is always a potential, but that has been misinterpreted in some to say that the Navy's not directly interested in JSF. We are interested because we know JSF, because of those technologies, because of the affordability and the survivability hedge it gives us on the future, is the complement we need on our carrier decks for the next century. Thank you.
Carlos, thank you. What we'd like to do is you've had a chance to listen to the Navy, Marine Corps requirements people. We're running a little bit behind. I'm going to go ahead and cancel the Air Force. And we would like to have brought you to. What we really will do, and Bruce, you'll have your day in the sun here, we're going to bring the U.S. Air Force and the Royal Air Force back for their presentations immediately after a break. And then we do have plenty of time for questions and answers. So please think of those during the break. What I'd ask you to do is we'll start that movie at about 3 minutes on the hour and ask you to be in your seats. When you hear that, when you see that 1 minute shot, please come back in and we'll get started right away. Thank you.
One joke.
Okay, no, I won't take it. I've seen guys give it before the guy in front of him? That's always a nice touch.
Listen to George Bush and Dr. Perry. And I took some notes. I'll tell you, Perry is, he could be the president, he could be the king, he could be your husband.
Okay, we're ready to get started again. Thank you for coming back. All the panel is just pleased that y'all came back. What I'd like to do is introduce next, I'd like to point out, I said this is not Dick, this is not Molnar, and this is not McGinn. What I would like to point out, this is their principal deputies that we have, and that's a unique view. These are the worker bees in terms of requirements for the Navy, the Marine Corps, and the Air Force. These guys work together often. You can see even their presentations, they don't step on each other. In fact, they're in lockstep. They go to the J-Rock. They make the presentation. So I am delighted to have the people that make up the slides present the slides. Brigadier General Bruce Carlson, United States Air Force, is the Director, Global Power Programs, Office of the Assistant Secretary of the Air Force for Acquisition in Washington, D.C. He is responsible for planning and directing acquisition programs to satisfy United States Air Force operational requirements within the Air Combat Mission Area. He was commissioned in 1971 as a distinguished graduate of the Air Force ROTC program. He has held a variety of assignments in flying units, Tactical Air Command and Air Command staffs, Headquarters U.S. Air Force, and the Office of the Secretary of Defense. He served as Senior Military Assistant to the Undersecretary of Defense for Acquisition and Senior Military Assistant to the Deputy Secretary of Defense in the Office of the Secretary of Defense. Before assuming his current position, he served as commander of the 49th Fighter Wing, Holloman Air Force Base, New Mexico. He's a command pilot in the United States Air Force with over 3,000 flight hours on aircraft including the F-4, the OV-10, the A-10, F-16, F and EF-111, AT-38, and F-117. Please join me in welcoming General Carlson.
Well, it's great to be with you. I thank General Anderson for that short introduction, and I know that some of you are disappointed that it's not Generals Dake, Molnar, and Admiral McGinn. I heard some conversation out here in the exhibit as I was walking around to that effect, and so I would just reinforce what General Anderson has told you, and that is that we really are the first team. We've briefed the TAC Air Caucus. This triumvirate here has gone to the J-Rock in lockstep. In fact, we're so well known now in circles in Washington that we're really known by our nicknames, Larry, Mo, and Curly. It's great to be back in the Tidewater and to address this group. I look out and see many people that I've known for several years. I'd like to talk, if I can get the next slide, please, talk just briefly with you about the Air Force portion of the Joint Strike Fighter program. I think Bob has talked about why the nation needs JSF. We've talked about why we need Stovall. I'll briefly review our perspective on that, and I think you'll find it complementary, matching with what my two previous friends have said. This is a joint program. We are excited to be part of this joint program. I think it has, at first, I served with General Anderson in OSD when this program was born as the JAS program, and I will tell you that it was, for the first few months, it was a little bit of a shotgun wedding. There was some forced happiness and some Novocaine smiles on the members of a number of the staff officers. However, over the past 2.5 years, this program has developed and matured, and now I think you'll find within every part of the three services and the growing number of foreign members of the team an enthusiasm over what we're about to see accomplished here. We really have an opportunity to break new ground, and we've been given by Dr. Kaminsky and before him Mr. Deutsch the edict to go out and break new ground in the development of a complementary series of airplanes. I'd like to talk then for just a couple of minutes about how we plan to use this aircraft and what our concept of ops is, and talk just a little bit about what we call the high-low mix in the Air Force. Well, I think you've heard most of these things before. We have dropped several other development programs in the Department of Defense in favor of this JAST and now JSF concept. We need to build an affordable airplane. And we know from our experience that in development, we spend about 5 to 10% of the total cost of a program. In acquisition, we spend around 45 to 55%. And then in the life cycle, over the life cycle, we generate the other 40 to 50% of cost of an aircraft program. So from the very outset, as Admiral Steidel and before him General Molnar walked into this program, they went in with the idea that their number one stockholder in the requirements business was affordability. And I like to think of it as if affordability, survivability, lethality, and supportability are all stockholders, affordability right now owns 51% of the stock. So as we make trades, we all services and all of our foreign members have as a goal this singularly important idea of keeping this airplane affordable. And that's especially important for us in the Air Force. We plan to buy over 2,000 of these vehicles, and that's almost 2/3 of the total buy of this airplane if you just project out what we plan to buy right now. So if that unit price goes up 10, 15%, this suddenly becomes an unaffordable airplane for the Air Force, and we just can't do that in today's environment. It's important that this airplane also be survivable, and we'll do that. The contractors will talk more about this afternoon, but there's a blended design that brings in a very aggressive, low observable signature, both in terms of the RF and IR, as well as a set of countermeasures that we are developing now as part of the F-18 and F-22 programs that will move into the JSF. It's important that the airplane can be lethal, and I think that lethality was demonstrated probably most aptly in Desert Storm as precision weapons really came of age. And the three services are continuing to develop that family of precision and highly accurate weapons in form of JDAM, JSOW, and JASM, and others, and those will be integrated as well as others onto the JSF to make sure that we develop that precision capability in an expanded operational envelope. Supportability is extremely important to us in the Air Force. We're an expeditionary force, unlike the Navy that has the forward presence available with the carriers. Most of our forces are maintained here or in selected few numbers of forward bases. And the size of our footprint, the amount of airlift that it takes to get us someplace is extremely important. The C-141s are wearing out, going away. They will be replaced by C-17s, but we're not buying very many of those airplanes. We don't have the excess airlift to take 20 to 24 141 loads to get a squadron into a theater, and then to continue to support it with a reduced airlift capability. The airplane has to be supportable in the long run. Next chart, please. We think it's, I threw this chart up because I think it's important that you understand a couple of things about the JSF. First of all, it's time to build a JSF. If you look at that big hump in the middle where you see on the top the B-1, you'll notice that in the decade of the early 80s, we bought the bulk of our F-16s and A-10s. If you look back another 20 years, you'll see that there would have been another hump there. We bought the bulk of our A-7 and F-4 fleet. So it's time now to replace that fleet of airplanes. In general terms, those airplanes are getting old. When we have an initial operational capability in 2010 for the first JSF squadron in the Air Force, the average age of the F-16 will be 24 years. Now, there are very few of you out there who are driving a 24-year-old automobile, at least driving it down the freeway. There may be some of you that take it to the beach on Saturday, but not operate with it openly. The second reason I throw this slide up is to tell you that this is an affordable program. You will hear much in the press, much from the Congressional Budget Office and the GAO about the $350 billion unaffordable TAC Air modernization program. I would tell you that, very simply put, that is just not true. If you look at this chart, you can see if you normalize these out to $96, this is a very modest program. We have gone from the A-10, F-111, F-15, F-16, F-15E, F-117 to, in the out years, essentially 2 airplanes, the JSF and the F-22. We are not buying an incredible number of these airplanes. We have scrubbed our requirements down to around 2,000 JSFs and under 500 F-22s. So we're not going helter-skelter into a program that has not been already constrained by budget and requirement. It is affordable, and it's time to do it. If we don't do it now, while we have the technology in hand and the program in place, that bow wave, that small hump, that small yellow hump that you see there, about 2010, is going to get pushed into the time when we need to modernize our tanker fleet, our trainer fleet, and then again our bomber and an airlift fleet. So it is important that we keep this modernization program on schedule. Next chart, please. This just highlights the fact that the F-16 fleet is running out of time. As I said, the airplanes will be about 24 years old, average age, when we bring on the very first squadron. And you can see...
53 participants and attendees, we want to let you know that the Ultrasport 496 helicopter will make a demonstration flight at 10:15. That's in the back, that's that display area, past the JSF area. At 10:15, the Ultrasport 496 helicopter will make a flight demonstration. Thank you.
So I have 4 minutes, I guess. The airplanes... If you look at the bottom of that chart, you notice the, and I will do my best so that we can all go see that, by the way. The A-10 has been with us a long time, and that airplane will age out of the fleet as well around 2020. So it's time to replace these airplanes. This is how we come up with our requirement. It's important to know that right now our F-16 fleet makes up about 65% of our force structure, our fighter force structure. That's what we have here, about 13 and a half wings of this complementary multi-role airplane. We buy about 100 airplanes per wing. That takes care of the training requirement. Then we have to buy some air defense airplanes. And then our plan right now is to also replace the 2.1 fighter wing equivalents of A-10s with the JSF. I think it would be a good time to bring up the Air Force Stovall variant. The chief has mentioned that. We think at my level that this is a good time to bring on the Stovall airplane into the Air Force, and you'll see us push for that over the next couple of years here as we further refine the requirements for the JSF. Next chart. I'd like to talk just briefly about what we call the high-low mix. We do that today, and we did it fairly well in Desert Storm with the F-15 and F-16. I think it will work very well in the future as we move into an environment where there are potential for concentrated areas of high threat, maybe not of the order of magnitude that we saw in the Soviet Union, where you'd have an integrated several thousand mile long air defense network. But we have seen, as we saw in Desert Storm, some very intense threat areas, both in terms of surface-to-air threat and air-to-air threat. The complementary nature of these two airplanes will allow us to poke holes in those defenses, allow the JSF to use the full capability that we're developing into the airplane. So we plan to buy a small number of F-22s, the high end, to poke those holes for us and ensure that we have air dominance, and then we can use the precision air-to-ground capability of the JSF. Next chart, please. This it's important to remember as we look at history and the way we've used air power. In the first night of Desert Storm, we attacked about 250 different targets. As you compare that with 8th Air Force during World War II, that's more than they hit in 4 years. So the capability to use air power with precision has developed exponentially over the years, and that capability is refined in this F-22 JSF mix. Our concept of operations allows us to use offensively the F-22 and JSF from day one. Because of its smaller logistics footprint and increased sortie generation rate, it has an increased capability to support the Joint Force Commander in the theater and ensure that the high-value assets that we and our sister services put into the area, like E-2s, E-3s, Joint Stars, U-2s, drones, UAVs, etc., are protected, and they can do their mission to further enhance the synergistic effect of this joint force team. Next slide, please. So, in our concept of operations, we think that the F-22 and the JSF form a very capable, affordable, and timely mix of aircraft to modernize our fleet and keep the force balanced and ready to fight our nation's next war. Finally, the Joint Strike Fighter will be the workhorse of our tactical forces in the future. It has to be affordable in order to meet that requirement because we intend on buying a large number of those airplanes. It has to be able to operate in an environment which I don't think we're able to predict yet. We have learned by experience that when we predict precisely, we know that we predict exactly wrong. So I don't know what the threat environment will be, but the way I think you and I and the public in this country want to win a war is the way we used to like to win softball games. And that is, we'd exercise the 11-run rule. And that is, you let the other guy bat first. He doesn't score any runs. You get up in the bottom of the first, score 11 runs. The other guy quits and goes home. We don't want to win the next conflict 3-2 in the bottom of the 10th inning. And this airplane will allow us to win by the 11-run rule. And finally, I think as both Admiral Johnson and General Magnus have talked about, as well as Admiral Steidl, the airplane has to be affordable. And I can't think of a better place to emphasize that than with the team of industrial people that will put the airplane together for us. So I look forward to your questions, and we'll talk more about it here later. Thank you very much.
Thank you, General Carlson. Bruce, do you have any idea how expensive it is to get an announcement like that made in the middle of a presentation? I'm shocked that General Kenny did it. Next, I'd like to introduce Air Vice Marshal Peter Norris, Royal Air Force. Peter joined the Royal Air Force in 1966. He was a flight instructor at RAF College Cranwell. He was posted to number 237 Operational Conversion Unit at RAF Huntington as Chief Flying Instructor. And incidentally, he was awarded the Air Force Cross in 1977 for his work at Huntington. He took command of number 16 Squadron RAF Larbrook, flying Hunter and Buccaneer aircraft in 1980. He then commanded RAF Marham From August 1985 to November 1987, was appointed aide-de-camp to Her Majesty the Queen for the duration of that tour. He served 2 consecutive appointments in the Ministry of Defense's Operational Requirement Staff, first as a group captain and then as Air Commodore. He moved to the Procurement Executive in November 1991 as Director General Aircraft 2. He attended Harvard Business School's Advanced Management Program before assuming his current position as Director General Air Systems 1, responsible for the procurement of the United Kingdom's fast jet combat aircraft. He has over 4,000 flight hours, is a Fellow of the Royal Aeronautical Society, and he sits on the Air Force Board of the Defense Council. Please join me in welcoming Air Vice Marshal Norris.
Ladies and gentlemen, thank you very much for the welcome and the introduction. It's a great honor to be here addressing the American Helicopter Society after this very exciting and successful year. And to do so in such a very joint atmosphere, a joint friendly one has been expressed. It's never been in the past quite as friendly as Craig alluded to with some of the inter-service rivalries. And the same was, of course, applied in the UK over time, as you would expect. Indeed, you may have heard the story of the 3 lads who'd been great friends at school, joined the 3 services individually, rising up through the ranks, and each of them was forever arguing the merits of his particular service, saying how much more his service contributed to the defense of the realm. And eventually they were up at the senior ranks, an Admiral General and Air Marshal, still arguing on the way to an international conference when their aircraft crashed, and prematurely they found themselves at the pearly gates. So they decided to ask Peter if God had ruled on the subject, and he said, we've heard your bickering over the years, he said, and we got a bit fed up with it up here. But we heard you were coming up this morning, so God's ruled. And it's shown just inside the gates there, on the board next to the 10 Commandments. Go read it. And they went in and they read it, and it said, each of the 3 services contributes equally to the defense of the realm. None is more important than either of the other 2. Signed, God, Air Marshal Royal Air Force. That might explain in part why I, as an airman, am here talking to you about what is essentially very much a Royal Navy project and a Royal Navy requirement. We have this year had, I believe, within the Joint Strike Fighter project, a truly successful year that's led to the timely completion of contract award for the concept demonstration phase, has led to more nations showing interest in the project, and an increasing commitment by all the participants, as I think has come out in the presentations thus far today. And this commitment to the Joint Strike Fighter is as strong in the UK as it is on this side of the Atlantic. And in a formal programme review last year, the UK government reaffirmed that the Joint Strike Fighter is its preferred option to succeed the Sea Harrier from the second decade of the next century. And in the course of this presentation, I'd like to re-emphasize the reasons for the UK's involvement in the Joint Strike Fighter project. We've committed ourselves as full collaborative partners in the concept demonstration phase, both because this program promises to fulfill a key requirement in the UK's force structure for the next century, and because we regard the project as a flagship of innovative and affordable aircraft procurement. And I'll explore in a little detail why it is that we've taken that position. The succession of very tight budget rounds in recent years in the UK has caused a substantial reduction in procurement expenditure over there and, of course, over here. And whichever party wins tomorrow's general election in the UK, this budget rigor shows no sign of being slackened in the coming years. However, our commitment to defence and to NATO and to ensuring that the UK armed forces are equipped to meet the challenges of the next century remain firm. Moreover, there's no sign that the range of military tasks that we're being asked to undertake is abating. Indeed, events in Bosnia, Iraq, and now in Albania demonstrate quite otherwise. Furthermore, historically, the cost of military aircraft, combat aircraft in particular, has spiraled ever upwards. Craig Steidl showed his Augustine's Law graph, and we've similar stories in the UK. In the First World War, we were paying £874 10 shillings, that's about $5,000 then, for a Sopwith Camel. By the Second World War, we had to pay about £6,000, which was about $30,000, for a Spitfire. And the next generation of UK air defence aircraft, the Eurofighter, is likely to come in at a unit cost of around £38 million. And that's an inflation rate of nearly 5 million% over the century. To reconcile this divergence in the level of defence budget with the increasing number of defence tasks and the cost of aircraft, it's essential that the very best value for money is obtained for every pound that we spend. And with the Joint Strike Fighter project, this aim is being achieved by adopting not just the best procurement practice, but also by innovating to suit the changed circumstances. And let me examine some of these procurement initiatives that Admiral Steidl and his team have taken. Each of these has the common aim of cost control and risk reduction, aims that we share completely in the UK. Generating the requirements jointly should lead to a high degree of commonality in the aircraft, which will grant cost benefits in the development and production phases from economies of scale, and in the in-service benefit area from simplified logistics support. A joint requirement at this very early stage should also avoid the need for making expensive alterations and modifications later in the development phase to accommodate the requirements of one of the partners. Holding competitions at each stage of the airframe procurement process has given industry the incentive to keep their costs down while ensuring that quality remains high. The benefits that competition bestows have been enhanced by the freedom that industry has been given to decide which sort of aircraft is needed to do the job economically. This freedom will permit industry to use its ingenuity to find the most cost-effective solution to the requirement, whilst at the same time maintaining a full dialogue with the officials on the program side. The rich prizes that these competitions potentially offer require that the source selection is seen to be fair and just. And that was most certainly achieved in the selection at the end of last year, and we've absolutely no doubt, difficult though it was, that the right decision was made. And UK officials were fully involved in this process for the Joint Strike Fighter, and I should like to pay formally a particular tribute to Craig Steidl and his team for the manner in which the whole of that down selection process was made. I also see the support of the alternative engine as a very positive step to ensure excellent value for money while reducing risk to the overall program. Value for money is achieved by focusing the supplier on the competitive advantages of performance, reliability, and affordability. And in this case, risk to the overall program is reduced on two fronts. Firstly, where the engine development is a high-risk part of the program, an alternative engine provides protection to the scheduled timescales. And secondly, and assuming that both engines are eventually selected, a major technical fault developing in one of the engines wouldn't ground the entire fleet. Those squadrons using the alternative engine would be available to support frontline effectiveness. And this belief in the benefits of an alternative engine is supported historically both here and in the UK. For example, with the introduction of the F110 as an alternative to the F100 for the F-15 and F-16, unit prices were reduced by about £1 million. And enhancements to cardinal requirements were also achieved. And in the UK, the introduction of the RTM322 engine for helicopter applications has had a similar beneficial effect in this area. The JAS Technology Maturation Program is key to the success of the Joint Strike Fighter. JSF will use leading-edge technology throughout, and this technology must be fully demonstrated to ensure a low-risk entry into future stages of the program. Money invested now in the technology maturation programs will pay back many times over in the course of the program as risks and their associated costs are reduced. A further initiative that is clearly of considerable importance to the UK and the Joint Strike Fighter project is that of bringing other nations into the program. This will help to spread the costs and risks of development and improve the export sales opportunities. The UK has taken the opportunity afforded to get deeply involved in JSF as a full collaborative partner, as you know. And we believe that working together gives the best chances of meeting all of our requirements at an affordable cost. It also has potentially substantial benefits for interoperability within the NATO framework. The multinational nature of the Joint Strike Fighter project is emphasized in the involvement of industries from both sides of the Atlantic. We believe that it's to everyone's advantage that a vigorous trade exists between our countries. For that reason, we welcome the fact that the prime contractors in the JSF project have shown themselves to be positive and forward-looking in using UK firms where the expertise they can bring into the program will make an important contribution, and where they've shown themselves to be competitive in both cost and performance terms. So those are the fundamental reasons why we, from a procurement standpoint, are very, very, very supportive of the Joint Strike Fighter project. So let me now move on to considering how I believe JSF will fit into the UK force structure during the next few years. As has been the case in recent years, it's anticipated that the UK will continue to require the ability to project military power at a distance from the British Isles to achieve our nation's strategic objectives. The origin of conflicts will remain worldwide and unpredictable, with concurrent but often unrelated action a distinct possibility as now. It follows, therefore, that our forces will often be required to react at short notice to commitments ranging from high-intensity conflict through to peace support operations, in many cases without geographical or host nation support being available. Protecting the UK, our dependent territories and our allies will also remain core defence roles, irrespective of the outcome of any defence review. So looking to the future, this combination of UK defence roles and commitments has led us to consider that we will need three prongs of long-range combat air and ground attack capability. Where we have host nation support, Eurofighter will provide both an air defence and offensive support capability. This aircraft is scheduled to enter service with the Royal Air Force at the end of 2001 and should shortly enter the production investment phase, leading to the start of full-scale production early next year. Its test program is progressing extremely well, and we now have all 7 development aircraft carrying out development test flying. Until about 2015, the Tornado GR4, with a mixture of smart and standoff weapons, will provide our longer-range offensive punch. This will be augmented by the Harrier GR7 and the T-10 force, which can also operate from smaller sites and aircraft carriers, such as our Invincible Class ones. And we're now also addressing the question of what comes after that. We've embarked on feasibility studies into a range of future offensive air system options, including Eurofighter derivatives, new aircraft, unmanned air vehicles, and standoff missiles. So there's no certainty that our future of...
Forum 53 attendees, Ron Bauer will be at the Land Sea Systems booth, booth 704, to talk about his famous and award-winning around-the-world flight. 7:04. Ron Ralph will be there to sign autographs and as well as the local media.
Great. However, so there's no guarantee that it's going to be an aircraft yet, although that is what is currently assumed pending the outcome of these feasibility studies. However, as I mentioned, we also believe that we'll have to operate far from domestic and allied territories to achieve our objectives. And in this situation, where host nation support cannot be relied upon, carrier-borne aircraft and the carriers with which to transport them are an essential part of the UK force mix. We will start formal consideration of the various options for the future of our aircraft carrier fleet later this year. In the longer term, the decisions on future carrier-borne aircraft and future carrier vessels are clearly inextricably linked. However, whatever decisions are arrived at for the future carrier-borne aircraft will spend at least some of its early years operating from the current Invincible class carriers. And this imposes a number of requirements and constraints on the design of the aircraft. These requirements show a great similarity to those of the US Marine Corps, although there are some minor aspects of variation between the two. The UK is, of course, committed to the four key pillars of Joint Strike Fighter: lethality, survivability, supportability, and affordability. And without these attributes, I would not be talking to you about our support for the Joint Strike Fighter today. However, I make no apologies for reiterating the specific issues that are of crucial importance to the UK in the progression of this project. Clearly, it's essential for the Royal Navy's Fleet Air Arm that any future carrier-borne aircraft is compatible with the Invincible class of carriers, known as CVSGs. These are smaller than the US carriers, and most significantly, have much smaller elevators, or lifts as we call them, on them. And rebuilding the lifts is highly unlikely to be affordable. One of our reasons for joining the program at this relatively early stage is to ensure that our specific aircraft sizing requirements are taken into account. The Royal Navy is a firm believer in ski jump assisted launches for short takeoff vertical landing aircraft, and hence the CVSGs are equipped with a 12-degree ramp, which has huge benefits to payload. Furthermore, the Invincible class carriers have a very compact area for deck parking of aircraft. As we intend to continue using our carriers for simultaneous operations, we're therefore particularly concerned about the temperature, pressure, and noise environments which will accompany the launching and recovery of JSF aircraft. The JSF concept is to provide an affordable and highly capable strike fighter for the US services and the Royal Navy. And the initial JSF requirement documentation identifies a range of roles to be fulfilled by the aircraft. And this multi-role requirement is particularly important for the UK, and we'll monitor this aspect closely during the forthcoming phases. And there are two reasons for this. Firstly, a small carrier with a frigate screen, its AEW aircraft and its fleet defense aircraft, is basically totally useless unless it's got the means of power projection embedded in it. And secondly, because the Royal Navy envisages many scenarios where UK carriers will be deployed in national-only operations or in the early stages of joint operations before other air forces have deployed to the theatre, we need to make sure that they've got this multi-role capability. Taking into account the relatively small capacity of our CVSGs and perhaps of their replacements, we'll not be able to afford the luxury of having single-role, fixed-wing aircraft in our inventory. Thus, it's vital that JSF will be a truly multi-role aircraft and highly effective in each role. Moreover, the ability to swing between roles within one sortie is also important, and indeed, the aircraft does sound well on track to being able to achieve that. The relatively small size of our carriers tends to accentuate JSF design considerations because of the restricted number of aircraft we'll have embarked. Features which provide for a force multiplier effect are therefore particularly important. For example, a highly reliable and easily maintained aircraft design and an efficient support infrastructure will help to get more aircraft into the air more frequently and quickly, and therefore the importance of the JSF emphasis on all aspects of supportability cannot be overstated. Space within our carriers' hangars is very restricted, and the capacity for carrying spares is also limited. In spite of these restrictions, it's the aim that 90% of all the maintenance activities on our future carrier-borne aircraft will be carried out in less than 8 hours. And to attain this rapid turnaround, the technical support capability of the Air Group must be optimized. It's essential to ensure that it is straightforward to identify and replace faulty systems with a minimum disruption to other parts of the aircraft. So, reliable onboard diagnostics are a must-have. And particularly close attention needs to be given to ease of maintenance. In aircraft designs where this has not been the case, long periods of inoperability may arise, even if the fault is quite minor. A good case in point is the engine in the Harrier, which a number of you will be acquainted with. If a fault occurs that requires engine removal, the wing has also got to come off, and that turns the whole process into an exercise involving several hundred man-hours of effort. And in the future carrier-borne aircraft, such a disruption will be unacceptable, since we must keep the aircraft operational for as long as possible at a time. From the operational viewpoint, the restricted number of aircraft embarked results in a premium being placed on features that provide the greatest number of weapons against an air or ground target from fewer aircraft. Obviously, the maximum weapons carrying capacity in a highly survivable configuration will be a major factor, but also the ability to operate from a deck alert status rather than from air patrol in the majority of air-to-air and air-to-ground missions will be important. And we'll be watching the evolution of these features closely during the development phase of JSF. It must be emphasized that these requirements are, in the main, matters that the UK shares equally with the United States. And where this is not so, the harmonization of requirements at this stage is a very important part of the process. As I touched on earlier, commonality across JSF variants will grant cost and risk benefits to all of us. And it's the UK's aims that these benefits are maximized by harmonizing UK's requirements for a STOVL aircraft with those of the Marine Corps. In conclusion, let me just pull together one or two of the threads that have led the UK to include that the Joint Strike Fighter project is the preferred option for the replacement of the Sea Harrier. We've seen that the UK requires an affordable multi-role aircraft with exceptional lethality, capable of operating from our invincible carriers. With the Joint Strike Fighter project continuing in its current manner, highly successful, this requirement should be fulfilled. Affordability of JSF should be guaranteed by the initiatives in procurement that I dwelt on in the earlier part of this talk. That JSF should be a multi-role aircraft with exceptional lethality is core to the concept. And finally, that it is compatible with our carriers should be ensured by harmonizing requirements during our involvement in this concept demonstration phase. So it's clear to me and to most of my colleagues back in the UK that the UK's essential requirements should be successfully met. It's certainly my wish that this early success is built upon in the course of this concept demonstration phase. And I look forward to that being satisfactorily concluded. And during this time, I can assure you that the UK will remain loyal and enthusiastic partners. Thank you.
Peter, thank you. Probably two things I ought to straighten out here. One is after last year's introduction, Peter told me it would not be necessary to mention that he is the president of the Royal Air Force Lawn Tennis Association, so I won't. The other thing is, it was described, in a defense publication that I introduced Peter last year as Air Vice Admiral. It's absolutely untrue. I'm fully aware that Peter can't stand the words Air Vice Admiral, and I would never mention Air Vice Admiral in the same breath with Peter Norris. So I appreciate that. Also, I'd like to point out we're ready for questions and answers. None of the panel members have been paid for this. At an earlier private meeting, we were promised the coveted AHS plaque. So I think you can open up, and we're well compensated and ready.